Right now, in one of the most remote and hostile places on Earth, a wall of ice the size of Great Britain is cracking apart in real time, and the scientists watching it happen are using a phrase they almost never use in public. They are calling it imminent. Not likely, not eventually. Imminent. A floating shelf of ice that has held back one of the most dangerous glaciers on the planet for longer than anyone alive has been monitoring it, is now fracturing so fast that researchers checking the satellite images have compared it to watching a windscreen shatter in real time. This is not a distant hypothetical warning about what might happen decades from now. This is happening this year, in 2026, and it concerns a glacier that has earned a nickname most scientists were originally uncomfortable using because it sounded too dramatic to be taken seriously. They call it the Doomsday Glacier. And after everything researchers have found in just the last few months, it turns out the nickname was never an exaggeration at all. Let's start with what this glacier actually is, because the scale of it is almost impossible to picture correctly the first time you hear the numbers. Thwaites Glacier sits in West Antarctica, and it is enormous, roughly 75 miles wide, making it the widest glacier on the entire planet, with ice in places more than 3,000 feet thick. To put that in a scale that is easier to hold in your head, the glacier alone covers an area comparable to the entire state of Florida, or to the island of Great Britain. It is not simply a large chunk of ice sitting at the bottom of the world. It functions as a structural pillar, a load-bearing wall holding back a far larger and far more dangerous mass of ice behind it, the West Antarctic ice sheet. A body of ice so vast that if it were ever lost entirely over centuries, it alone contains enough frozen water to raise global sea levels by more than 3 meters, or roughly 10 feet. Thwaites itself, just the glacier, not the ice sheet behind it, holds enough ice to raise sea levels by about 65 centimeters, a little over 2 feet, entirely on its own. Scientists who study this system have a blunt way of describing Thwaites' role in the whole picture. They call it a cork in the bottle. Remove the cork, and everything behind it starts to move. For years, the thing standing between Thwaites and open ocean has been a floating extension of the glacier called its eastern ice shelf, a slab of ice roughly 45 kilometers across that does not sit on land, but floats directly on the ocean, anchored in place partly by an underwater ridge on the seafloor. Its job, in the simplest possible terms, is to act as a doorstop. It physically pushes back against the grounded ice behind it, slowing down how quickly that ice can flow forward and eventually break off into the sea. As long as that doorstop stayed in place, Thwaites' retreat, while already underway, was at least partially restrained. That restraint is the thing scientists are now telling us is about to disappear. Robert Larder, a marine geophysicist with the British Antarctic Survey, who helps coordinate the international research collaboration studying this glacier, put it about as directly as a scientist can put something in a public statement. The last bit of ice shelf in front of the glacier, he said, is poised to disintegrate. He was equally direct about the uncertainty involved, admitting that researchers do not know exactly how this ice shelf is going to break up, only that it is definitely going to go. That is not hedged, cautious academic language. That is a senior glaciologist telling the public plainly that a structural feature holding back one of the most dangerous glaciers on Earth is not a question of if anymore, only a question of how and exactly when. The evidence backing that statement is not speculative. Satellite imagery has shown the eastern ice shelf fracturing precisely where you would expect the most catastrophic failure to begin, at the underwater ridge anchoring it in place, and at the front where it meets the main body of the glacier, the 2 points where the ice is under the most mechanical stress. Larder and his colleagues have tracked movement on the western portion of the shelf roughly doubling over just the past 8 months. Christian Wild, a geophysicist at the University of Innsbruck who has also studied the site closely, described the flow rate of the ice shelf tripling between January of 2020 and January of 2026. Now moving at just over 2,000 meters a year, a rate of acceleration he described, in his own words, as nuts. Wild has also described what the satellite images actually look like as the fracturing accelerates, comparing the shattering pattern spreading across the ice to a windscreen breaking apart. Large sections simply falling to pieces where before there had been a single, mostly intact sheet. This is the part of the story where it becomes important to slow down and be precise about what scientists are actually saying, because it would be easy and dishonest to take these facts and turn them into a headline promising an imminent apocalypse. That is not what the researchers studying Thwaites are claiming, and it is worth being exact about the distinction, because the real picture is both more serious and more nuanced than a simple countdown to disaster. What is imminent, according to the scientists actually monitoring this system, is the loss of the eastern ice shelf itself, potentially as early as this year. What is not imminent, and what no credible researcher on this project is claiming, is the sudden collapse of the entire glacier, or an overnight surge in global sea levels. Thwaites is enormous, and even without the protective ice shelf in front of it, The process of that grounded ice flowing into the ocean and eventually contributing to sea level rise unfolds over decades and centuries, not months or years. One recent study modeling the glacier's future projected that by the year 2067, Thwaites could be losing between 180 and 200 billion tons of ice annually. A staggering number, but one that represents an acceleration playing out over more than 4 decades from now. Not a sudden event. Scientists have also found reason for a small amount of caution in the opposite direction. Some of the most alarming theoretical scenarios modeled in past years, involving something called marine ice cliff instability, a mechanism by which extremely tall exposed ice cliffs could physically collapse under their own weight in a rapid, self-reinforcing cascade, now appear less likely according to some of the newer computer models than researchers originally feared a few years ago. The Doomsday nickname captures something real about the stakes involved, but not necessarily something real about the speed of the outcome. So what is actually driving all of this, and why now? The mechanism scientists point to again and again is not warming air. It is warming ocean water, and understanding that distinction matters, because it explains why a glacier sitting in one of the coldest places on the planet is melting from a direction most people never think to look. Changes in wind patterns across the southern hemisphere have been drawing relatively warm water up from the deep ocean and funneling it directly underneath the glacier, where it attacks the ice from below, right at the point where the glacier meets the bedrock and the seafloor, the single weakest structural point in the entire system. This is, in a sense, the worst possible place for melting to occur because it undermines the very foundation the ice is resting on, rather than simply thinning the surface from above, the way most people picture glacier melt happening. Researchers using an underwater robot called IceFin, deployed by the International Thwaites Glacier Collaboration, have captured direct images of exactly this process, warm water funneling through, deep cracks and channels in the ice, actively accelerating the melt from underneath in a way that is extremely difficult to slow down once it has taken hold. One study from this research group found that seawater has been detected moving more than 6 miles beneath the glacier itself, a discovery that surprised even researchers who had been expecting to find significant ocean water intrusion. Perhaps the most unsettling finding to come out of this research in the past year is not about what is happening now, but about when this process actually began. Using satellite records combined with GPS data collected directly on the ice, researchers determined that Thwaites' retreat did not start recently, or even in the past few decades, when climate change first became a widely discussed public issue. It appears to have begun as far back as the 1940s, potentially triggered by a powerful El Niño event that warmed ocean currents enough to start the glacier's slow, accelerating retreat generations before anyone was monitoring it closely. Since the early 1990s alone, Thwaites has retreated roughly 12 miles, about 20 kilometers, and that retreat has been accelerating, not slowing, in the decades since. Eric Rigno, a glaciologist at the University of California, Irvine, who has worked on this research collaboration for years, has been careful to emphasize just how much uncertainty remains in translating these findings into a precise, confident forecast for how quickly this will all unfold. That uncertainty runs through the entire scientific conversation around Thwaites, and honest reporting on this topic has to sit with it rather than paper over it. Estimates for how much sea level rise this glacier and the ice sheet behind it could ultimately produce vary dramatically depending on which researcher and which model you ask. Some climate scientists point to projections suggesting global sea levels could rise by around 4 meters by the year 2100 if current emissions trends continue unchecked. Others studying the exact same system arrive at estimates of only 1 to 2 feet of contribution from Thwaites, specifically, over a much longer, multi-century timescale. One glaciologist studying the region put the honest state of the science about as plainly as it can be put. Frankly, he said, nobody knows. That is not a scientist failing to do their job. That is a scientist being honest about the genuine limits of modeling a process this complex, playing out in a place this remote, involving ice sheet dynamics that have never been directly observed by human instruments until extraordinarily recently. What is not in dispute across every research group studying this glacier is the direction of the trend. Thwaites is retreating faster than it was 5 years ago. It is retreating faster than nearly every model built even a decade ago predicted it would by now. The eastern ice shelf, the one remaining natural break slowing the glacier's advance toward the ocean, is fracturing in a pattern, and at a speed that researchers describe as unlike anything they have observed in over 20 years of continuous monitoring at this site. And removing that break, whatever the precise timeline for the consequences turns out to be, changes the fundamental physics of how quickly the grounded ice behind it can begin flowing toward open water. There is also a broader risk sitting underneath the story of Thwaites specifically, one that explains why scientists across the world are watching this single glacier so closely instead of treating it as an isolated regional concern. Thwaites does not exist in isolation. It functions as one of the primary structural supports for the wider West Antarctic ice sheet, and researchers are concerned that if Thwaites destabilizes significantly, the loss of that support could begin to destabilize neighboring glaciers as well, a kind of slow-motion domino effect across the ice sheet that would take the consequences of Thwaites' retreat and amplify them across a much larger portion of West Antarctica's total ice mass. This is precisely why researchers describe losing the ice shelf as something closer to pulling a goalie late in a hockey game than losing a single contained structure. The shelf's removal does not just affect Thwaites. It opens up the possibility of faster ice loss across a system that, in its entirety, holds enough frozen water to reshape coastlines around the entire planet. It is worth being clear about what that reshaping would actually mean for people in concrete terms, rather than leaving it as an abstract number on a chart. Sea level rise on the scale researchers are discussing, even the more conservative estimates measured in single feet rather than meters, translates directly into more frequent and more severe coastal flooding, accelerated erosion of shorelines, and growing threats to the infrastructure of coastal cities around the world, including major population centers like Miami and London, along with some of the most vulnerable, low-lying regions on the planet, including Bangladesh and small island nations across the Pacific. None of these consequences require the full, dramatic collapse of Thwaites to begin. They accumulate steadily as sea levels rise incrementally, year after year, driven by exactly the kind of accelerating ice loss researchers are now documenting in real time at the glacier's eastern edge. This is also why the research effort behind these findings has been so extensive and so international. The International Thwaites Glacier Collaboration is a joint research program between the United States and the United Kingdom, bringing together glaciologists, oceanographers, and engineers to study this single glacier system from nearly every angle available to modern science. Satellite monitoring, tracking surface movement and fracturing in near real time, ice-breaking research vessels, carrying scientists directly to the glacier's ocean-facing edge, underwater robotic vehicles like IceFin capturing direct images of the melting process happening beneath the ice where no human diver could safely go, and ground-based GPS instrumentation recording the physical movement of the ice itself with a precision that would have been unimaginable to researchers studying this region even 20 years ago. Earlier this year, a team of researchers and engineers attempted to establish a camp directly on the rapidly changing ice shelf itself, hoping to install monitoring instruments beneath the glacier to gather even more direct data. The attempt to plant that equipment ultimately did not succeed, a reminder of just how difficult and dangerous fieldwork in this environment remains, but the team still managed to gather valuable measurements from beneath the glacier's main trunk, data that confirmed the water moving beneath the ice is both warmer and moving faster than previous estimates had suggested. One more piece of evidence pointing toward the same conclusion coming from multiple independent directions at once. So where does this actually leave us right now in the middle of 2026? The eastern ice shelf holding back Thwaites Glacier is fracturing faster than researchers have ever recorded at this site, with movement that has tripled in 6 years and doubled again in the past 8 months alone. And the scientists watching it happen are telling the public, in plain and direct language, that its disintegration is no longer a distant hypothetical, but something that could unfold within the current year. That does not mean coastal cities flood tomorrow. It does not mean Thwaites Glacier itself vanishes into the ocean next year, or even within most of our lifetimes. The physical process of an ice sheet this size fully retreating unfolds over centuries, shaped by ocean currents, ice dynamics, and climate patterns that researchers are still working to fully model, even with the extraordinary amount of direct observation now available to them. What it does mean is that one of the last natural checks slowing that long, centuries-spanning process down is about to be removed, and every serious research group studying the glacier agrees that removing it accelerates what comes next, even if they do not yet agree on exactly how much or exactly how fast. The honest, unglamorous truth sitting underneath the dramatic nickname is this: Thwaites is not a ticking bomb set to go off on a specific date. It is a slow, massive, deeply consequential system that has been changing for longer than most of the researchers studying it have been alive. And that system just crossed a threshold nobody fully expected to arrive this soon. The last break is coming off. What happens in the years and decades after that is still, by the honest admission of the scientists who know this glacier best, something nobody can predict with total confidence. But every piece of data currently coming back from Antarctica points in the same direction. And it is not a direction anyone studying this glacier finds reassuring. If you want to keep following what happens as this ice shelf finally breaks apart, and what the world's leading glaciologists find. When it does, subscribe and stay close because this story is unfolding in real time at the bottom of the world right now.